click on it and press delete. Click on it and press delete. And I still want to be finding those with my next graph. It could be any minimum and maximum. It doesn't matter because we just want to complete one whole cycle. So I'm going to get these guys. And look at how quickly I can do it if I just press the numbers as opposed to click, 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 enter, click, 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 enter. Okay, so amplitude. Notice the y values, 2 to negative 2. My total distance is 4. Again, halved is 2. Are we starting to see connections between these equations and the amplitude? And then our period is the distance between maximum to maximum. So the distance is always a subtraction, right? The difference is the distance between those numbers. Subtracting those out, I get 120. And remember, it's the x values from maximum to maximum that we're subtracting out. And in the principal axis, we haven't shifted up or down. And so our maximum and minimum are still like 2 and negative 2. So the number in the middle is still just 0. So it's y equals 0. Okay. Last one. Notice we went from 2 here. We kept it and then multiplied by 3. And now we have the same thing, but we're just adding 1. Thinking about transformations, what do we think is going to happen? Let's see. When we add 1, I'm just going to hold on to the white spot and drag it up so I can see it a little bit more. When we just add 1 or add or subtract numbers outside of the parent function, the transformation there is a vertical shift, right? So we vertically shifted up 1. Okay, so the placement of our maximum and minimum, our points were nice and went with us this time. Our maximum is still distance apart of 270 and 150, right? So my period, I could still just subtract those guys and get 120. My amplitude, still a total height of 4, right? From 3 to negative 1 is still a distance of 4. So divided by 2, because your amplitude is just half of that, is 2. And then the only thing that's changed is the number in the middle. How you find that number in the middle when it's not just easily at 0 is that you can add these two numbers together, finding the average of them, right? You add those two numbers and then divide by 2. So 3 plus negative 1 is 2, divided by 2 is 1. But also realize it's just this number right here, y equals 1. Okay, that is it for what we're going to do together. What I would like for you to do is now graph these next ones, these next 3 on your own. You can either look at the graph and try and figure it out from there, or you can try and use the relationship between the equations up here and what you noticed in this down here. So go and try that on your own. When you graph these next guys, it's cosine now instead of sine, which is fine. I'm going to delete these old points. Amplitude now is 0.8, right? Going down negative 0.8, going up 0.8. Period is still going from 0 to 360, so our period is 360. And then our principal axis, everything's just smack dab in the middle, y equals 0. Hey, notice your amplitude is always just the number that it's being multiplied by in the very, very front. Okay. Now, when we go in and divide by 2 on this guy, instead of squishing it all, when we multiplied by 3, when we divided by 2, it expanded it. So I'm going to go in and change my window a little bit. I'm going to like maybe do 800. So grabbing my next maximum, I see that now my amplitude is a distance from 0 to 720. So not my amplitude, my period is now a distance between 0 and 720. Principal axis still in the middle, and our amplitude is still 0.8. So what happens inside of your trig function affects your period. So notice here that when we multiplied by 3, it was 360 divided by 3. When we divided by 2, it was 360 times 2. So the opposite of what you think is going to happen is what happens inside of the trig function. And it's always with period. So when we minus 3, it's just a vertical shift down by 3. We still have the same amplitude. We still have the same period. And now just our middle line is at -3. And when you do that, you can see that it shifts down by 3. And it can all be found within your equation. You don't have to look at the graph. So summarizing all of these pieces together, your amplitude is equal to, if I write out the idea of these functions, y equals a sine of bx plus d, 3 unknowns. So keep that in mind for systems of equations. Or cosine. We only do sine or cosine in this class. A will always be your amplitude. The number in front of either sine or cosine will always be your amplitude. Remember that amplitude is a distance, so it can't be negative. So if it was -3, it would flip the graph, but it would still be a distance of 3 for your amplitude. So I'm going to do the absolute value of A because it should just be positive, whatever it is. Now, if you were looking at it on a graph, it's your Y values, remember, and it's from your maximum Y value, subtracting out your minimum Y value and then dividing by 2, right? It's that total height divided by 2. And the idea is that it's the vertical stretch of the graph. The amplitude is your vertical stretch of the graph. Okay. Your period is always started with the idea of your universal period, which is one complete cycle is 360 degrees. So you always start with that, with the formula. And then you divide out whatever b is. And technically, because period is distance, you divide out the absolute value of b. We just take the positive value of whatever b is and divide it out from 360. So b here was 3, so we divided out 3. Technically, b here is 1/2, right? We divided by 2, which is the same thing as multiplying by 1/2. And since b is here an operation of multiplication, we should think of this instead of as division, more like multiplication. And so instead of thinking about it as dividing by 2, we think about it as multiplying by 1/2. So we would divide 360 by 1/2, which is the same thing as multiplying by 2, and so it becomes 720. We'll practice this together in class. So it's just take whatever that b value is and divide 360 by it. Or if you're looking at it on the graph, it's your maximum of the x, the second x value, minus the maximum, your first x value. So you're taking your two maximum x values and subtracting them out. Or you could take your two minimum x values and subtract them out. The idea is how long it takes to complete one cycle. Okay, the last thing that we want to talk about is the principal axis. And the principal axis is just y equals d. No absolute value, no anything. If it was shifted down 3, then your principal axis is now at y equals -3, right? So this is the only one that isn't like a distance. It's just wherever the line is, and it's just whatever your d value is. You could also take the average between your two y values, between the minimum and the maximum. So you could take your minimum y value and add your maximum y value, taking those two y values, adding them together because you're trying to find the average, right? Which is adding the values together and then dividing by how many you added, which will always be 2 in this case because you're only taking those two values. So you're just finding the average between those two. And the idea of this one, I ran out of room, is it's the horizontal line of symmetry, but not really symmetry because of stuff. Okay. Let's go ahead and practice this. I don't want to take too long on these notes, so we're just going to continue pushing through. So we're going to just look at this equation and find the amplitude, period, and the principal axis. So remember that the amplitude is always just the absolute value of A. Well, in this case, A, B, and D, right? A is 3.7. So the absolute value of 3.7 is 3.7. The period is always equal to 360 divided by the absolute value of B. B, in this case, is 2. So your period would be 180. And then your principal axis is always just y equals D. So it's y equals -2. You can go ahead and graph this and see for yourself. I encourage you to, but I don't want to waste your time by doing something that you could just do on your own. And you can see that this is true. So you can grab all of these things just from the equation. You know a lot about the graph already by just looking at the equation, which is why we talk about these in the first lesson. So we have the equation here for this next example shown on the calculator screen down here as well. So we're going to write down the amplitude, and it says justify your answer. And when it says justify your answer, it just means show mathematically, right? So mathematically, we're going to show that the amplitude is what we say it is. So we can see here that we're going by units of 10 on the x-axis and units of 2 on the y-axis. 10, 20, 30, 40, 50. This looks to be at 60. 10, 20, 30, 40, 50. This looks to be at -60. These are going up by units of 2. 2, 4, 6, 8, 10, 12, 14, 16, 18, 20 here and here. So writing down the amplitude, it looks like our amplitude here is, again, looking at the y values, right? 20. And we can see here that our amplitude, our A value is -20. And remember that our amplitude is always the absolute value of A. So it's the absolute value of -20. And so our amplitude is 20. And we've justified it mathematically. We can also just see it on the graph. And then it says to write down the period of the function and also justify our answer. Again, just mathematically. We can see that we're going from -60 to +60, which is a distance of 120. We can also show it by taking 3 and dividing it out from 360. So our period is equal to 360 divided by the absolute value of B, which is 3. And 360 divided by 3 is 120.